Here I'm going to show you some examples of writing equations in the different forms that we learned about yesterday. Standard form would be the one that probably used the least, but then we'll have slope-intercept, one of the most common, and point-slope form, which I think is going to be very helpful to us. In this first one, notice we want to write the equation of a line that has a slope of -3/2. We know that. And we know it goes through the point 6, 8. Also notice it doesn't tell us which form we have to put it in, and what I'm going to do is I'm going to show you how to put it into all three forms, just in case it tells you one specific one. Now in this problem, technically, you take the one that you want to put it into, write that equation, and then you can be done with it. But like I said, for the sake of being able to show you all of them, that's what I'm going to do. The first one I'm going to look at is slope-intercept, being that's probably the most common one. And what I'm going to do is I'm going to start off just by writing our equation y equals slope m x plus and then our y-intercept of b. And what I'm going to do is I'm just going to start this equation. I know the slope is -3/2, so I can put that in. And really that's kind of one of the only things that I know as far as the equation goes. But I also know that x and y in the equation represents every point on the line. And being I have one, I can take that one point and I can put it into my equation. My x value is 6, my y value is 8, and now the only variable that I have left is b. So if I could solve this for b, well, then I have my slope and I have my y-intercept. Go through, solve this, multiply, I'm going to end up with -9 here. 8 plus b, add my 9 to both sides, and I just found out that my b, or my y-intercept, is 17. Therefore, now I can come back to my equation. Y equals, there's going to be m, x plus, and then my b. M, slope is -3/2. B is 17. Right there, I have the equation of a line that has a slope of -3/2, and it goes through the point 6, 8. Another way to look at this, I'm going to take this and I'm just going to bring it down. The way that I personally like is slope-intercept form. In slope-intercept form, we have y minus something equal to our slope, and then it's x minus something here. We said our slope was here, and then if you remember, this was y value, and this was an x value for one point that's on our line. Well, I look at this again, I have that point, I have the slope, I have everything I need to write the equation of this line. It's just a matter of plugging it in. So I have y equals, I'm just going to write down everything that never changes, like so, and now fill in the blanks. Slope is -3/2. My y value at my point is 8. My x value is 6. Right there is the equation of a line that goes through the point 6, 8 with a slope of -3/2. The only other thing that we would have to do now is maybe have to put this into standard form. Now, standard form, our x's and our y's are on one side and the constants on the other. And it doesn't really matter which approach you take. Maybe you want to start with this equation. Maybe you want to start with this equation. Either one, take one of them, start there, and then work on moving all your x's to one side and all your y's to one side. I'll go with this one just because this is the last one that we did. So think of this as kind of something new here as far as coming up with standard form. Solve this equation as far as getting x and y on one side. I'm going to distribute to start. Actually, you know what? I'm not going to do that. I'm going to take a different approach. I am going to multiply both sides by 2 because I don't like to deal with fractions if I don't have to. And in standard form, there are no fractions. Now, when I do that, I'm going to have 2y minus 16 here. And on this side, I'm going to take that -2 and multiply by the 3/2, so I'll have -3. And then I still have that x minus 6. And then I can go on, don't have to worry about these fractions. Distribute. For whatever reason, I'm going to distribute on the right side first. left side doesn't change. Now I'm going to do a lot of moving all at once. Remember the coefficient of x has to be positive. Right now it's negative. If I add it to the other side, I'm going to have a positive coefficient for x. My x's and y's will now be on the same side. I got to get rid of that minus 16. I'm going to add it to both sides. Now I'm left with 3, oops, that was an x. 3x plus 2y, and it's going to equal 34. And there I have standard form. So standard form was here. I scroll up here. This was point slope form. If I go up even farther, here was our slope intercept form. All three forms were one line. This one's a little bit different because now I have a point and I have slope, just like last time, but this point is special this time. Should circle it. What I want you to think about is where does that lie on the coordinate grid? And if I were to plot that point, 0, -3, it's going to end up somewhere about here. Notice that's on the y-axis. It has a slope of 2. My line's going to look something like this. But the big thing here is that green point, that's your y-intercept. What I can do is I can write my equation in slope-intercept form and be done. It's a matter of filling in the blanks. Y equals, tells me the slope is 2. You know what I forgot up here was the x. Put it in there. Plus my y-intercept, which I know is now -3. I have the equation of my line. It's all done. And if you needed to put it into point slope form, you could do it just like we did on the last example. If you needed to put it into standard form, we could take this equation and we could manipulate it, get all the x's on one side, all the y's on the other. I'll tell you what, I'm going to put this into standard form using this equation. And being my x coefficient's already positive on the right side, I'm going to move all the x's and y's to the right side and the constant to the other. Which means I'm going to have to subtract y from both sides, but I'm also going to have to add this 3 to both sides. Which leaves me with 3 equal to 2x minus y. And technically, if it's in standard form, the x's and y's are on the left side and the constant's on the right. So here is standard form. And here again was our slope-intercept form, depending on which version you need. And then again, if we needed it into point slope form, I'm going to take this and bring it down again, just so I have all my information. Well, point slope form looks like this. Remember, your slope is right here. Coordinates of your point go here and here. And now I can just plug it in. Have my point, have my slope, put those in the right spots, and we'll be set. So I'll put my slope in first. I'm going to put in my point second here. And then put in all the black. It never ever changes. So y minus equals our parenthesis x minus parenthesis. There it is in point slope form. Now this one is different because now it gives us the coordinates of 2 points. We get no slope. What you have to think about is if we're going to put it into point slope form or slope intercept, we have to have the slope. Therefore, I'm going to have to take my 2 points and calculate the slope. So the slope of our line, do 9 minus 5, and then 4 minus -2. End up with 4 over 6 for a slope of 2/3. Now what I would do is I would put this into point slope form because I think it's the fastest. And it really doesn't matter which point you use. Just step here a little bit so we know our points. I'm going to take it. I'm going to write down all the black that never ever changes. And I'll fill in the blanks. Slope will go right here. I'm going to use that first point in this equation, therefore I put a 5 here and a -2 there. Now, like I said, it doesn't matter which one you use. So if I use the other one, it's going to look like this. Looks different because we have different numbers in it, but the equation is, if you were to graph this line, it's still going to be the same line, not any different. And the reason that is because I would challenge you to take one of those equations, it doesn't matter which one, actually take both of them and solve them for y. In other words, get the y all by itself. And if you get the y all by itself, it'll be in slope-intercept form. When you do that, you're going to end up with y equal to 2/3 plus, or 2/3 x plus 19/3. 2/3, that shouldn't change because there's your, whoops, I should kind of color coordinated. 2/3, you're going to have your x plus, and then that y-intercept you find out, kind of a little bit of a messy decimal, comes out to be, or not a messy decimal, but a messy fraction, comes out to be 19/3. So if you took this equation, solved it for y, you get this. Take this equation, solve it for y, you still get the same slope-intercept form. And then I want to look at this one. This one, it gives us a point that we want our line to go through. Notice now this time, I want it perpendicular to this line. Now why did I circle the 4/7? Because I look at that equation, y minus 8 equal to 4/7, and then x plus 513. It's in point-slope form. So I can look into that equation and find the slope. I know the slope of this line is 4/7. Therefore, the slope of my new line is going to have to be the opposite reciprocal. It's going to have to be negative because the other one's positive, and then the reciprocal of 4/7 is 7/4. I have my slope. I have my point. I'm going to write my equation into point-slope form. My slope that I came up with, -7/4. The point that the problem gave me, y value is -5, x value is -2. I have my equation. And I know some of you are going to change this to a plus sign, that's fine. Change this to a plus sign, that would also be fine. And you may need to, like I did in on the other examples, manipulate this into slope-intercept form or into standard form. So those are some examples on taking information about a line and writing an equation of that line.